In this video we'll be going over the solutions to practice test 2 from trigonometry. This is an assignment that I gave in one semester, first time in fall of 2013, and this is, we're going to be going over all this. I purposefully only answered one question and then just got out so I can go into the review section. This will have the correct answers displayed, but we're going to go over how to get all of them. So here we go. The first question is a unit circle is a circle with center at blank and radius equal blank. Well, the unit circle is the center at the origin and radius 1. Next question. For the value of real number s, find sine of s, cosine of s, and tangent of s. Well, s is pi over 2. Of course, pi over 2, when you're taking a initial side, put it in standard position, which would be initial side here on the positive x-axis. We rotate an angle of pi over 2. That is, if we take this to be 1 here and 1 here, this arc length, if we rotate around to pretend that's a circle, that arc length s is our angle theta, which is pi over 2. And of course we know that we have a terminal side that's here. We find any point on the terminal side and find an x, y, and r. So if we do a radius of 1, r equals 1, x and y for this point, x is 0, y is 1. Then sine is y, so sine is 1. Cosine is x. Well, sine of theta is y over r, which is 1 over 1, which is 1. Cosine of theta is x over r, which is 0 over 1, which is 0, and tangent of theta is y over x, which is 1 over 0, which is undefined. So sine of s is 1, cosine of s is 0, and expression for tangent of s is undefined. Next question. Which are the circular functions state which circular functions are undefined for negative pi. Okay, so angle of negative pi would rotate this way to here. So that's the angle of negative pi. And we see that, for example, we could land at the point r equals 1, x equals negative 1, y equals 0. And the ones that are going to be undefined are the ones where you're dividing by 0. And here you see, so you're dividing by y. None of these divide by y, so sine, cosine, and tangent are going to be defined. But then the reciprocals of these are cosecant of theta is r over y. Secant of theta is r over x. And cotangent of theta is x over y. Which ones are we going to be dividing by 0? Cosecant and cotangent. So those are the ones that are undefined. The rest are defined. Okay, what if the angle is minus pi over 2? Then we're rotating to here, straight down, and so now this time, again, so theta is negative pi over 2. We could take one point on the terminal side to be r of 1, x is 0, y is negative 1, and so anytime we're dividing by 0, any of these that have x on the bottom, that would be secant there, and tangent are undefined. So tangent and secant, select those two. Find the linear speed of a point traveling in a circular path where s is the distance. Let's see if I can make this fit just a little bit better here. Okay. We have the linear speed of a point traveling a circular path where s is the distance traveled in time t. So s is the actual length traveled around the path in time t. So we have a, here's the center of a circle. We go out, we're traveling around this way. And so it goes 8, s equals 8 feet. And it does it in t equals 2 minutes. So the linear speed is just distance divided by time. So the linear speed, we'll call that, usually it's called v for velocity. So the velocity is 8 feet for every 2 minutes. So that's 4 feet per minute. We reduce the fraction there. So 4 feet per minute. Now if we wanted to find the angular speed, we need to know the radius. So let me just throw something else in here. Suppose the radius is 2. What would be the angular speed? Okay, the angular speed omega. Okay, so let's think about this a minute. Remember, we have our basic setup that what's the difference between the theta and the arc length s? Well, the arc length is the radius times theta. So if radius is 1, the arc length and the theta are the same if you're measuring in radians now. Okay? So if we divide both sides by, so we do the change, fix the radius r, do the change in the angle times the r is the change in the arc length, divide that by the change in time. This is our velocity, our linear velocity, or linear speed. This is our angular velocity, omega. So r times omega equals v. So here we would have v is 4 feet per minute. And if we have an r is 2, we can solve for omega by dividing both sides by 2 to be 2. R is 2 feet, and the feet cancel that, and is 2 per minute, which means 2 radians per minute. And of course we could convert that to degrees per minute or revolutions per second or whatever. We could convert that. Okay, a little extra than beyond what they asked there. Okay, so the next one does ask about angular speed. Theta is 3 pi over 4 and t is 5 seconds. Well, the omega is just the change in theta over change in time, which is basically what they're giving us here. So the change in time is 3 pi over 4, and the change in angle and the change in time is 5 seconds. And so just work that out. That's 3 pi over 20 per second. And you can write radians or not write radians, either one, because radians is technically not a unit. So 3 pi over 20 per second, or 3 pi over 20 radians per second. Next question. Alright, we've got a bicycle wheel that are 30 inches in diameter. So we've got a wheel across here is 30 inches is the diameter, so the radius is half of that, which is half of 30 inches is 15 inches. Okay, and so if it's going 25 miles per hour, find the angular speed of the wheels. How fast are the wheels moving around? So remember, r omega is v, so this side is 23 miles per hour, and so r is 15 inches, and so omega is 23 miles per 1 hour. Divide by 15 inches, so it's 1 over 15 inches. Now, we need it just to be per hour, which is essentially radians per hour. So we need the distance units to cancel out. So we do have to do a little unit conversions here. 12 inches is 1 foot, and so the inches would cancel out. And 5,280 feet is 1 mile. And when we do that, the feet and the miles cancel out, and we're just left per hour. So this will be radians per hour, and that's what we want. Okay, so let's now compute this with the calculator here. So it's 23 divided by 15 times 12 times 5,280, and that is 97,152 per hour. And of course this is radians. You can write radians or not write radians, it's still the same. And that should be the answer they're looking for. 97152, correct. next one. Okay, hard disks or circular disks that store data in your computer. A circular hard disk is 3.5 inches in diameter. So the diameter is 3.5 inches, so that makes the radius half of that. That's 1.75 inches. Okay. Divide that with a calculator if you have to, but you should be able to divide in your head there. It rotates at 7,500 revolutions per minute. Okay. How far is the point on the edge? Well, we need to figure out omega in radians per minute. So we multiply this by 1 revolution is 2 pi radians. Okay. Then we're going to get in radians per minute. And radians really isn't a unit, so we can actually leave that off. So this is just per minute. Well, I'll just leave it this way. We'll just leave it like that for right now. Okay, and that's omega. So if we have r times omega, so this part here is omega. And so we have r times omega, so we need to put r here, 1.75 inches. And this will be v. R omega equals v. Okay, let me clear this out here. Okay. So when you look at your units and make sure everything's going to work out. Revolutions cancel. We get radians per minute times inches. Radians, basically, we can leave that off because that's not really a unit. So we get inches per minute, which is a legitimate velocity unit, and it's the one they want. So we just put this in, 1.75 times 7,500 times 2 times pi, and we get 82466.80716 inches per minute for our velocity, and it says to go to 2 decimal places, so we want to that number's bigger than 5, so we add 1 there. Okay, next question. Okay, in this question here, we'll be selecting which of the 6 basic trigonometric functions have this property in question. To provide an answer, we'll type lowercase letters of all the correct answers in alphabetical order as if it were a single word. Be sure to include all the answers that apply. For example, if you think that it should be sine, cosine, and cosecant have the property sine, cosine, and what did I say? Cosecant, that would be A, B, E, and you just type A, B, E in the blank. Okay, so which ones is f of minus x the same as f of x? That's that's y-axis symmetry or even function. That's cosine and its reciprocal secant. So that's B and D. A couple ways you can think of it. Think of it with if you've got the graphs basically memorized. Remember, cosine starts here and goes down like this, so it's going to have y-axis symmetry. If you have an x here and an x here, opposites, they're going to have the same y. We can also think of it on the unit circle picture. Okay, so the input in here, what's x in this formula is actually theta over here. So if you have an angle theta here, and then you have the opposite theta here, notice that these are going to line up so they have the same x but opposite y's. So which ones depend basically only on x and r? Because r is the same all the way around the circle. Well, that's cosine and its reciprocal secant. For which one do we get opposites? Well, again, you can look here at this picture and you can see it as all the rest of them are going to have the same absolute value for the sine in both of these terminal sides for the angle, but for both theta and minus theta, or x and minus x. For all these have the same absolute value. The cosine and the secant has the same sign. They're both the same sign. Either are both positive over here, or both negative over here. But they've got opposite signs for all of the others. Now, of course, what that gives you is something like, for example, sine looks something like this, that's going to be origin symmetry. So if you rotate this around 180 degrees, you get the same graph back. Same thing works for its reciprocal, of course, and then also that works for tangent and cotangent as well. Has origin symmetry, so if you rotate around 180 degrees. So that happens when you have that. Pi minus x, if we think about the unit circle picture, and where is x? So x is a theta over here. So again, I'm just going to draw one in the first quadrant here, but it can be any quadrant. If that's theta, pi minus theta is the supplementary angle over here. So it has the same reference angle, and these are going to have the same height. So same y, but opposite x's. So if that's theta, this angle going all the way to here is pi minus theta. So this is theta here for the reference angle, if theta is an acute angle anyway. And so, but in any case, in all the cases, you get the same y. So which ones are the y's the same? Or y, it only involves y and r? Well, that would be sine, and then its reciprocal cosecant. So sine and cosecant would be a and e, so you type in AE for the answer. So which ones, when you get over here, do you get the opposite? Okay. Oh, by the way, how does that look on the sine wave here? If you look at a particular value here and you do pi minus that value, where this distance is the same as that, you get the same. You're at the same height. Okay. There it is for first quadrant angle anyway. Okay. Whereas if you do the same thing for cosine, you're going to end up with opposites. Cosine, say it looks like this. Here's pi here. If you move over a certain amount here, you get a value. That value there is the same value something here, where this distance and this distance are the same. Except, guess what? One's positive, one's negative. So the opposite signs on all the others, B, C, D, and F. Now, what is this saying? It says if you go around a half circle rotation, so again, if this is theta, if you go in another half circle, this is a straight line here. So this one around here would be pi plus theta. And notice they have congruent reference angles. So all the trig functions, the absolute values of them are going to be the same, like the sine of theta and the sine of pi minus theta. Their absolute values will be the same. But what about the positive and negative part? Well, which ones are these both the same sign? Well, they're both positive this way, or over here both negative if you have tangent or cotangent. So tangent and cotangent are the ones we're looking for here, which is C and F. So C, F should be the answer. And then the ones where they're opposite would be all the rest of them, A, B, D, and E. So notice that this says that the period of tangent and cotangent is going to be pi, because they repeat. They all repeat when you go a full circle, but tangent's going to repeat once you start a half circle rotation. Similar kind of question here, but this is asking about the periods. So this one says, for which of these functions is f of x plus n pi equals f of x for every integer n? They all have that for some integers n, but for every integer n, that only happens for tangent and cotangent, just as we discussed. So this means that these have a period of pi. Now, which of these have f of x plus 2n pi equals f of x for every integer n? All of them do that. So which have period 2 pi? Well, A, B, D, and E, that's sine, cosine, secant, and cosecant have period 2 pi. Tangent and cotangent have period pi. So even though they do repeat, the period is going to be the shortest amount you can repeat. And of course, we can also see this on the graph because, for example, in sine, you got a sine wave. It goes from 0, the basic one, y equals sine of x, goes from 0 to 2 pi. And then the wave repeats again. So it repeats one full cycle in any distance of 2 pi. Cosine does the same thing and so forth. Tangent does it, say this is minus pi over 2 to pi over 2. and then this is a distance of pi, and then guess what? It repeats the whole thing again. So it repeats every multiple of pi. Still talking about properties of the basic trig functions, which have domain all real numbers, sine and cosine, A and B. They're defined no matter what. Notice that they're in the unit circle picture, they're x over r and y over r for cosine and sine, respectively. R is always non-zero, it's always positive, so they're always defined. Okay, but the others, all the others are either dividing by x or y, so when one of those values is 0, they're undefined. So which are undefined when at multiples, every multiple of pi. So every multiple of pi says your terminal side is going to be either straight this way, even multiples of pi, or straight this way for your terminal side. Well, in either case, what happens here, the y value is 0. So any of the trig functions that divide by y, so like r over y or x over y, those would be undefined. Well, which are these? R over y is, well, y over r is sine, so r over y is cosecant, and y over x is tangent, x over y is cotangent. So this is cotangent of our theta, and this is our cosecant of theta. So cosecant and cotangent are undefined at those places. So cosecant, E, and cotangent, E and F. Good, that's correct. Okay, which ones are undefined? Now notice if n is every integer n is an integer. 2 times that is an even integer. Add 1, that's an odd integer. So here we have odd multiples of pi over 2. Okay, so in the unit circle picture, that means pi over 2 is straight up, and then 3 pi over 2 is straight down. So terminal sides here are here, and so those are ones where x is 0, and so when x is 0, they're going to be undefined. So which ones are those going to be? Well, those are going to be r over x or y over x. Well, that's tangent of the theta. R over x is secant of theta. So secant and tangent are ones that are undefined there. So that's D and C. So CD should be what they wrote there. Correct. Now, another way you could see these things is just think of the sine and cosine graphs. And say here it is on 1 period. 0. There. Pi over 2 goes up to 1. So this is really sloppy graphing, but 3 pi over 2 goes down to -1. Okay, and notice that anytime sine is 0, that means that its reciprocal, which is going like this, cosecant, is undefined, and so forth. Okay, this particular one is going to be when cosine is 0. Both of these, or when x is 0, and both of these are going to be undefined. So which ones are continuous? Well, sine and cosine are all one continuous wave. Which ones have vertical asymptotes? Well, all the others have vertical asymptotes. Now, where could they be? Okay. Which one have asymptotes at multiples of pi? So they have asymptotes at 2 pi, 0, and at pi, and at minus pi. Okay, which ones are going to have asymptotes there? Well, there's going to be the one that goes down like this. Oops, not there. Sorry, none of them do that. It's up here. Okay. And here, which C is cosecant, right? And then also cotangent also comes down like this. So you can do it by memorizing the graphs. You can also do it by thinking of the unit circle. Okay, so n pi is going to be, the terminal side is either going to be straight to the left or straight to the right, and both of those have a y of 0. So which ones are undefined when y is 0? Well, there we go. And so basically this question here, question 2 and question 5 are going to be the same, because every one of these trig functions, it's continuous everywhere except places where it's undefined, and where it's undefined it has vertical asymptotes. That's for all of them. So the ones that are undefined at x equals n pi, e and f, which are cosecant and cotangent, those are going to be exactly the same ones that have asymptotes there. And likewise 3 and 6 are going to be the same answer, because every one that's undefined at 2n plus 1 pi over 2 is going to have an asymptote at that same x value. So which ones have a range of all real numbers? Tangent and cotangent are the ones that go all the way, and you can think of it, I can just think of it maybe from the graph. There's tangent, one period of it, and cotangent, one period here. So just one period alone takes care of all real numbers. All the others have gaps. Now, sine and cosine are always between 1 and -1, and they go up and down like this, bouncing around between 1 and -1 without ever going above it or below that. So the range is -1 to 1. Secant and cosecant then go outside of that. So they go from 1 to infinity and from negative infinity to -1. Okay. Alright, next question. So you definitely need to know these basic properties of these basic graphs. Okay, let's talk about some y-intercepts. Which ones have a y-intercept of 0, 0? Which ones start at the origin? Well, we know sine starts there, right? And it goes up. Tangent also goes through there. Okay, cosine is going to start up here at 1 and come down. Secant is going to start at 1 and go up. And then the other two are undefined at 0. So sine and tangent, so A and C. Which ones start at 1, 0? That would be cosine, and then its reciprocal secant. So B and D. And which ones don't have a y-intercept? Well, the other two don't have, they have vertical asymptotes there. They're undefined. That's E and F, which is cosecant and cotangent. What about x-intercepts? Well, they all have infinitely many x-intercepts that occur periodically, except for the secant and cosecant, which you know are up here and down here. They have this part between, including the x-axis, between y equals 1 up here and y equals -1 down here, where they don't go inside of that. So they don't touch the x-axis. So D and E don't touch it. The others have periodic places where they do touch it. So we can think of it in the unit circle picture. We can also just think, if we've got their graphs sort of memorized, okay, where does the sine wave goes like this. Remember, this is a 2 pi, pi, 0. So this is all multiples of pi, n pi. So that would be sine. And tangent also turns out to go through the same places. Okay. So which ones are at the places in between here? Well, cosine does that, and cotangent does that. So cotangent comes down like this, and cosine comes down like this. Next question. Relative extrema, maximum, minimum. Okay, so again, think of the basic sine wave. Okay, that's a sloppy sine wave. Let me see if I can do a little bit better than that. Okay, let's go here. Let's do it like this. I'll make this a little better, a little bit prettier graph this time. Okay, so it starts at 0, goes up to 1, back down to 0, back down to -1, back up to 1. So this is not a square scale. This is 2 pi, pi. So this is pi over 2, 3 pi over 2. You should memorize this picture. This is 1. This is -1. No, that was pi. That's pi. Okay, so basically memorize that. That's for sine. And sine has a maximum then. Where does it happen? Well, at pi over 2, and then any shifts of that. So pi over 2 plus 2n pi 1 is a maximum of sine. So that's question 2. Okay, what about cosine? Okay, if I graph cosine on the same kind of a scale, it goes like this for one period. And again, the same values. 2 pi, pi over 2 here, 3 pi over 2 here, -1, 1 here. It has a maximum at 0, and then shifts of that by 2 pi. So multiples of 2 pi, comma 1, that would be cosine. Which ones have a maximum at -pi over 2? That would be right here. That's where sine has a minimum. Where sine has a minimum, its reciprocal has a maximum. So cosecant has a maximum there, plus shifts of that by 2 pi. So -pi over 2 plus 2n pi, -1. That's should be cosecant. Okay, which ones have a local maximum at 2n plus 1 pi, comma -1? So this is odd multiples of pi. So that's where that would be right here, and the one that has a maximum there is the reciprocal of cosine, which is secant. Ones that don't have a maximum at all are the tangent and cotangent, because they go on up forever, up and down forever. How about minima? Which one of these has a minimum at 2 pi, 2n pi, multiples of 2 pi, and at 1, comma 1, okay? So multiples of 2 pi at 1, that would be like right here. Which one has a minimum there? Well, this one, which is secant. Which happens to have a local, that's a local minimum. A local minimum at an odd multiple of, or at pi over 2 plus shifts. So pi over 2 comma 1, that would be right here. And it needs to be a minimum, so the one that has a minimum there is cosecant. Okay. Wait a minute. Pi over 2, yeah, that's there. Which have a minimum at -pi over 2 plus shifts and -1. So that would be right here. Which one has a minimum there? That's sine. Which one has a minimum at odd multiples of pi? So at pi, right here, and then over again at 3 pi, which would be here. Not here, it'd be over here. Okay, well, that's the one that has a minimum there is cosine. And tangent and cotangent don't have minima. So which one of these is their local extrema, also global extrema? That's sine and cosine. So in other words, it's the highest. If it's the highest point in this little neighborhood, it's the highest point overall. That's not true for secant and cosecant, because say cosecant down here, this is the highest point here, but it's not higher than up here. In fact, there is no highest point overall. So only sine and cosine have global extrema. Okay, so let's talk about the characteristics of cosine of x. The domain is all reals, that's f. The range is from -1 to 1, that's f here. The x-intercepts are, well, let's look back at the cosine graph. That's the one in the middle right here. The x-intercepts pi over 2, 3 pi over 2, odd multiples of pi over 2. So let's see how we can say that. 2n plus 1 times pi over 2, and of course y is 0 for the x-intercepts. Similarly for sine, this one right up here is sine, the one in the middle, right here. Okay, so the domain is all reals. The range is -1 to 1, same sine and cosine. And the x-intercepts are 0, pi, 2 pi, multiples of pi, where y is 0. So we get B. All right, how about tangent? I don't have tangent drawn over here. Let's do a quick sketch of tangent. Tangent's going to go like this, and then again, and again. And what are these guys? That's 0. This is pi. This is 2 pi, etc. This is pi over 2, negative pi over 2, 3 pi over 2. Okay? The domain is all reals except for these guys where it has the asymptote, which are odd multiples of pi over 2. 2n plus 1 times pi over 2. Okay? And so x equals those values will be vertical asymptotes. The range is all reals, negative infinity to infinity. The x-intercepts are, let's see, 0, pi, 2 pi, multiples of pi. So n pi sits it, and then y is 0. In general, a function f of x is periodic if and only if there's a positive number p such that f of x plus p equals f of x for all x in the domain. And in fact, if that's true, then f of x plus n times p will also equal f of x for all integers n. So they're looking for f of x. The period of sine, cosine, cosecant, and secant is 2 pi, while the period of tangent and cotangent is pi. Next question. Okay, describe how the y values of the function y equals sine of x change, as they increase or decrease, from one x to the next. So, select the correct answer. Okay, so for A, we're going to, as x increases from 0 to pi, we're looking at the sine here, as x increases from 0 to pi, sine is going to go up from 0 to 1. We can also think of this as the unit circle picture. As theta goes from here to here, the y values are going to go from 0 to 1. Okay? So you can answer these questions really based on a unit circle understanding, or based on memorizing what that graph looks like as well, or graphing on your calculator and describing what you see. So a couple ways to go at this. As x increases from pi over 2 to pi, the y values on the unit circle go from 1 down to 0, so they decrease, and that corresponds to this part of the graph right here, between here and here, where x is where the y values decrease. So y decreases from 1 down to 0. And then as you go from pi to 3 pi, from here to here, the y values here decrease from 0 down to -1. And of course that's what happens here as well in this part of the graph. So decrease from 0 down to -1. And the last one probably is to finish up the circle. Yep. From 3 pi to 2 pi, then we see the y's increase from -1 back up to 0. And that's what's happening on this part of the graph right here. On the graph from -1 to 0. Okay, let's look at the graph of tangent of x. And we can also think of tangent of x as looking at this tangent line. And remember, this distance here is tangent of theta. Okay, so, but we can also just look at it from the graph here. As x increases from 0 to pi over 2, tangent goes from 0 to infinity. From 0 and approaches infinity. Increases. And as you go from pi over 2 to pi, that's this part of the graph. Okay. And we're going from minus infinity to 0, increasing. From values approaching infinity up towards 0. Next one here, the next piece from pi to 3 pi over 2, this piece, we're increasing from 0 to infinity. And then the last piece here, we're going from minus infinity back up to 0. So just a quick look at the graph really is probably the easiest way to do that. Secant, let's see which one's secant. Secant's this one right here. Here. So the first piece is from 0 to pi over 2. It's increasing from 1 to infinity. From pi over 2 to pi, it's increasing from minus infinity to negative 1. From pi to 3 pi, it's decreasing from negative 1 down, from pi to 3 pi over 2, it's decreasing from negative 1, down to negative infinity. Okay. So that was C. And then D, as it goes from 3 pi over 2 to 2 pi, we're talking about this part of the graph right in here. Okay, it's decreasing from infinity down to 1. Okay, so we want to look at cotangent equals negative 1. When does that happen? Okay, where's the cotangent? Cotangent, of course you can graph these on your calculator, but cotangent looks like this. And if you go 0 to pi, you get 1 period. And then again. Okay, so when does it equal negative 1? Well, it's exactly halfway between here. Okay, so this is pi over 2. This would be pi over 4. This would be 3 pi over 4. So 3 pi over 4 will be one place that it does that. Now it's going to do it if you shift it over by pi. So 3 pi over 4. If we add 4 pi over 4, the next place over here is 7 pi over 4. If we go over more than that, we're past 2 pi. But we also can look at some spots over here on this side too. So if we subtract 4 pi over 4, subtract pi, we get minus pi over 4 for this x-coordinate of that guy. And of course all the y's here are negative 1. And then let's subtract another pi, which would be negative 4 pi over 4 plus this is negative 5 pi over 4. That would be this guy right here. And if we go out more than, if we subtract another pi, then we're past negative 2 pi. So these are only ones that are in that interval. And that's what we have here. Of course, you have to enter these with the symbol palette. Period of sine is 2 pi. The period of sine of bx is 2 pi divided by the absolute value of b. So it's the normal period. If you replace x by bx, what you're doing, and compared to y equals sine x, you take the original period here, 2 pi, that's a horizontal distance, and we're taking all those things and we're actually dividing them by b. So divided by the absolute value of b will be the period. So there's the period, or the absolute value of b is 2 pi over the period. So that gives you a nice thing. You do need I don't know if I did absolute value when I did this before, but you do need absolute value here in case b is a negative. If b is a negative, you also reflect this thing over the y-axis. But the period is usually stated as a positive value. Okay, so then we need absolute value for b. Y equals 3 tangent of x, match it with its graph. Of course, we can just graph it on our graphing calculators, and certainly we can do that, but we know that tangent, okay, this is going to be 3 times as tall as normal. So it's still going to hit the x-axis at 0 and at pi. There's one period of it, not one connected period. Connected up there. Okay, and this is still pi over 2. But it's going to be 3 times as tall. So instead of being pi over 4, 1, this is going to be at 3. So you can look for the one that looks like this shape right here, but it goes through pi over 4 and then 3. So halfway in between here, it needs to go up to 3. Has not been flipped over. Okay, So they've got them in a different order down here, but it doesn't look like these at all. Looks like more like one of these, and it's the one that's going up, so it's this one. And if they gave us more than one that looked like this, we'd need to look at our scale, and we'd see here that pi over 4, we're about here. Yeah, that's about 3, so that looks good. Six sine of x, it's just going to look like a regular sine of x, but it's going to be 6 times as tall. So this time when it does this little deal here, okay, it's still going to go over the same places, 2 pi, pi, and 0 for where it crosses the x-axis, but now it's going to go up to 6 and down to negative 6. So, which one does that? This one looks like a cosine that's been shifted, stretched. This one's been sine that's been shifted up. This one has a minus in front, so it looks like a minus 6 sine of x because it's been flipped upside down. This is going the right direction here, and it does go at 6 there, in the right place, and the range is negative 6 to 6. So we change the amplitude. Now this one takes a regular cosine, which normally starts at the top, and it flips it over, and so it flips it upside down like this, and stretches it so that that's at negative 6 on the y-axis. Negative 3 on the y-axis. Okay? Now we also have 6x, so the period now is 2 pi divided by 6, or pi over 3. So this guy right here is going to be pi over 3. Of course, this will be half of that. This is pi over 6, and this is pi over 12, and this is 1 pi over 2, 3 pi over 12, which is pi over 4. And so we get something that looks like that for one period of it. So the period is pi over 3, or 1/3 pi. The amplitude is the absolute value of that coefficient 3. So this is going up to 3 and down to negative 3, where it hits here and here. Here. So the absolute value of that, so this distance here is the amplitude, which is 3. And which of these looks like it? Well, it should start down low and come up. Let's see, they all do that. No, not that one. So we eliminate C. It's going to start down at negative 3, and this one's the wrong scale, so throw out D. So now we're down to these two here. Now let's look at the period. It's got to cycle all the way through once between 0 and pi over 3, and so that's A. And of course you can graph that on your calculator as well and check it that way if you want. But there should be very few times you actually have to pick your calculator up here. So we have a graph, but you can certainly use it to check things. So we have y equals a tan of bx, or y equals a cotangent of bx here. Well, where b is positive, a is not 0. Actually, there's okay. So notice it goes through the origin. So the one that goes through the origin, we have not done a horizontal shift with this one. So cotangent has an asymptote there, so that's not going to work. So it's going to need to be a tangent, but it's also decreasing like cotangent does. So the tangent's been flipped upside down. So we know that the A is negative. Okay. And let's see here. So let's see. So 0, this is pi over 2, and then this is negative pi over 2. So the period is that distance, which is pi. Well, that's the normal period. So that says we didn't change the period. So B is 1. And we flipped upside down, so A is negative. And then we just need to look right here at pi over 4 and see what it turns out to be. Whatever that value is, that's going to be A. So it's negative 3. So negative 3 tangent of x. Where was I? do that one last. Okay. 28. In the sine curve y equals a times sine of bx minus c, the amplitude is the absolute value of a, the period is 2 pi divided by the absolute value of b, and a cycle starts whenever the thing inside is 0, whenever the bx minus c equals 0, which of course is when x equals c over b. Amplitude, period, and phase shift of the following functions. So by the way, this on the last one, that's called the phase shift. The c over b on that last one. Okay? So this one, you put the 2x minus pi when that's equal to 0. So 2x equals pi, x equals pi over 2. That's going to be our phase shift. Okay? And the amplitude is the absolute value of the a, so that's going to be absolute value of 2 is 2, so that's the amplitude. The period, okay, the period is 2 pi divided by the absolute value of b, so that's 2 pi over, well, absolute value of 2. The 2 I'm talking about is this coefficient of x here. And so that's just pi, so the period is now pi. Okay, so what's that going to look like? Well, let's see here. So we start with the cosine. It's going to cycle all the way between 0 and pi. Okay, it's twice as tall as normal, but instead of starting up here, the top starting at 1, the cycle is going to start over at pi over 2. So everything's shifted over 1, and it starts up at 2, so it goes down here, here, and then back up here and starts here, so it goes like this. Okay, could also be done as this would also be equal to what else? Sine of, so notice this is shifted by pi over 2. We could have just done it with a sine and worked it out as well. So okay, yeah, that's correct. This is it here. They've got, this is not the axis, this is pi over 2. So notice that's pi over 2, this is 3 pi over 2, so that's one cycle going between. If we continued over here, they're drawing this part of the graph. So they're drawing it starting where it normally does, but that starts at pi over 2. Okay, and it goes down to negative 2 and up to positive 2. So that's one cycle. Is that the... Okay, here's another similar question. So the amplitude is absolute value of 2, so that's 2. The period is 2 pi divided by 4, so that's pi over 2. The phase shift is when the 4x minus plus pi over 2 is equal to 0. So 4x equals negative pi over 2. Divided by 4, x is negative pi over 8. So it's going to start at negative pi over 8. It's going to start up above, up here at 4. And then it's going to come down from there. And the period was, what was the period? Pi over 2. So it's going to, what's negative pi over 8 plus pi over 2, common denominator of 8, 4 pi over 8, plus a negative pi over 8 is 7 pi over 8. So somewhere over here is 7 pi over 8. That's what it's going to get back up here. It's going to kind of do something like that. Graph it on your calculator. Let's see to check it. But that's going to be something like this one, starting above here at negative pi over 8. Both of these do that. It should cycle once to 3 pi. 4 minus 1 is 3. 3 pi over 8, yes. 3 pi over 8. It should cycle, which is what this one does. Find an equation for the graph. Well, probably it looks like kind of like a sine wave or sine or cosine wave. It starts at the origin, so it looks like it'd be easiest if we just start with the sine. Y equals sine of x. And then, in fact, that's our only choice, because if we do a cosine of bx, now it hasn't been shifted horizontally, so that would start either at 1 or negative 1, depending on whether a was positive or negative, or a or negative a. So sine is going to start at 0, and how far up does it go? It goes up to 4 and down to up to 3 and down to negative 3, and it starts going up like sine normally does, so it has not been shifted, or not flipped, so that's 3 sine of something x. Now let's figure out what the period is. One period is pi, and so the b is 2 pi over the period, so that's 2 pi over pi is 2. 3 sine of 2x. A couple more. Okay, and this one we are doing a regression. Okay, so we need to use our calculator for a regression. Let's go over that real fast. So you go to Stat, Edit, go up to List 2, hit Clear and Enter. List 1, put it on the label, Clear and Enter. So now it clears those out. We can type in our x's, which will be the months. 1, enter, 2, enter, 3, enter, and so forth, until I get all of the months in. Seasons are amount of hours of daylight is exactly modeled by a sine or cosine function, and so temperatures, average temperatures, also follow the seasons as well. So this ought to work out pretty nicely for a sine wave. Okay, now I'm entering the values for the. Well, I'm doing this without any mistakes. Entering the values for the y's. Almost without mistakes. There we go. Alright, so now we have x and y values in. I want to go to y equals. I want to turn these things off and turn on plot 1. And so that will turn it on as plot 1. If I already have plot 1 set up right, that's all we have to do. But in case you're not sure about plot 1, a couple things you need to do. First of all, you need to make sure you're in radian mode. Be sure you're in radian mode for this entire test. Okay, very important. Anything to do with graphing needs to be radian mode. So we want this type of plot. So notice I did second y equals for stat plot. It's a scatter plot. X's are in list 1, Y's are in list 2. The mark is there. That's exactly what we want. Now we do zoom 9. If you don't remember 9, look for it. It's zoom stat. And so this will graph this. Well, that looks like it could be part of a sine wave. So it makes sense that it might be a sine wave. Also, it's basically going to cycle over each year. So this should be a function that has basically has a period of 12 months. So it should have a period of 12 here. Okay. So let's see what the calculator comes up with. And we can go to Stat, Calc. I'm going to do up arrow because I'll get to it faster. Sine regression, C there. And X list, Y list is list 2. I can force a period, and it makes sense for the period to be 12 months here. So I can force a period there, and I can store my regression equation as y1, which I can go to variables, yvars, function y1, and calculate that. Let's do that again. If you could pause the video right at the right place, you can see the order of the syntax. that you type it in if you do not have the statistical wizards that I have. So when I hit enter, look at it very quickly, and you can see it'll say sine reg L1 L2 Y1, and it'll enter that period in there someplace, and let's see what the right order is for that. Okay, so the period comes in before the so the syntax is like this. Actually, no parentheses. So you just type in sine reg. You give it its x list, y list, period, and where you're going to store it. So if you don't have the stat wizard like I've got, you just type it in like that. And you should get this, and this gives us a formula of this form: y equals a sine of bx plus c plus d, and so our a is 25.87, sine b was 0.4998, x plus c is negative 1.965, and then plus 41.978. Now they're probably going to round these off. Okay, so let's see which one that they give us is the closest to this. Okay, well they're factoring this out. So they're factoring out this should be a half. Okay. Alright. So they're wanting us to do this a different way. I wish it wasn't done like this. Okay. So what you're going to need to do here is you're probably just going to need to go ahead and just graph these and see which one works. It's not going to give you the same thing as this over here. Although it should be fairly close on the center line. About 42 for the center line, so that tells you right away that it's got to be this one. And that's going to be about the same as averaging all these y values here, more or less. The amplitude is about 25 point something. Okay, and so again, this one does here looks about right. Notice that when you have so we have the phase shift of 4 months, so it's going to hit an average of 0 4 months in, or the average temperature is going to be about 4 months in, and the pi over 6 says the period is going to be 2 pi divided by pi over 6, which is our period of 12 exactly that we needed. So that part should be correct. I don't know why that one didn't force a period of 12 before. So graph that with it. So that's the one they want us to use, not this one. So this is our plot here, and if you look at that graph, that's quite close. Okay, so let's plot the one that they wanted us to use. Okay, which is 25.5 sine of pi over 6 times x minus 4, close another parentheses, plus 42.5, and I'm going to make that one, when I look at the picture here, I'm going to move over here and hit enter there, and that's going to make that a dark line when I graph it. So here's the dark line. How does that look? Well, it also looks pretty darn good. Okay, and so which one of these is the graph? Yeah, D is the graph there. Now, it wants us to use the function values for the model. So rather than using the table to get there, so 1 is 17, April, January, February, March, April, that's 44, and July is 68, and October is 44. It's wanting us to use, that's using, that if we could find those if we did trace, and we followed along the actual values here. But if we down arrow, this is the regression model the calculator came up with, and down one more, this is the model that they are wanting us to use. So now I can just do trace and type in different values, like 1 for January, and it's 17, and April is 4, so that'll trace to 4 using that model that they want us to use, and it's 42.5. And July is the 7th month, so type in 7. That traces to there and gives us 68. And October is the 10th month, which is 42.5. Of course, we could also go on to our table. Say go to table setup. Say start at 1, go up by 1s automatically, and look at our table, and we can see y2 is the values that the model they're using, and y1 is the regression equation the calculator came up with. Well, certainly the computed values are quite close. A couple of them are straight on. January and July were the same. April and October were not the same, but close. So is the graph verified? Yes, it is. One more. Okay. Given a, so we want it to be y equals, let's just go down here, y equals a times sine of bx minus c plus d. Okay. And the max is 18 and the min is 10. So that's a total distance of 8. So the amplitude is, so the d is the average of these two. 18 plus 10 over 2. Min plus max divided by 2. So that's 28 divided by 2 is 14. So that's the d. The amplitude is going to be half of that distance. So it's max minus min divided by 2. So that's a distance of 8 divided by 2 is 4. At least that's going to be the absolute value of A. Okay, so the absolute value of A is 4. So I could, and the minimum happens when X is 10. And the period is 40. So this is plus or minus 4 sine. Okay. Now, it happens when the period is 40. Okay, so let's work that out. So the period is 2 pi divided by absolute value of b. So 2 pi, so b, absolute value of b, is 2 pi divided by the period. So that's 2 pi divided by 40 is so absolute value of b is 2 pi over 40, which is pi over 20. Okay, so let's see, we've got that. So this is pi over 20. Alright, so now we just need to figure out the c. Okay, so a sine wave, if we don't flip it over, a minimum is going to happen right there. Okay, and let's say the period is 40. So a cycle goes all the way from here to here. This would be 40. 0 to 40 if it's not shifted. So what we could do is we could shift this guy over this way 10 to 10. Okay, that's one way we could do it. That could be the phase shift. Okay, so the phase shift is when bx minus c equals 0. So x is c over b. So that's 10 there is c over b. So c is 10 times b. Well, b was 2 pi over 40, so c could be 10 times that. That'd be 20 pi over 40 is pi over 2. Let's see here. Uh, 2 pi over 40 is pi over 20. Let me see here. See if I got the right thing here. B is pi over 20. So 10 times pi over 20 is pi over 2. So we could shift to the right by pi over 2. So this could be plus pi over 2. So they're shifting by they're saying by pi. So let's see here. Sometimes there's more than one way to do this. More than one way to do the shift. So if we start by going from 0 to 40, this would be sine of, and this is 4 sine of pi over 20x plus 14. Okay, and that's not 0, this is 14 right there. But it's 0 for x. So the x-axis is way down here somewhere. Okay, and so this is going from 18 to, from the top, and the bottom is 10. Okay, now it's saying we want to, where does this normally happen? This happens at, if this is 40, this is 20, this is 10, this is 30. So I could take this one and shift it to the left 20. Let's try it that way. It's a little bit different way than what they did it. So I shift to the left 20, I replace x by x plus 20. So I put it in there, and this is going to get the one that they want. So 4 sine pi over 20, where there's an x, put x plus 20. Like that. And then I'm just going to distribute and get pi over 20x plus, the 20's cancel, pi plus 14. So that'll work. That will work right there. Okay? So B, for the answers they gave us, B would have to be used rather than these other two. Alright, so I believe we've gone through all of the problems. You can use this to help you study for the practice test and for the actual exam.